Here in this video, we are solving AIPMT questions in current electricity. Let me start with this first question. Both of them are slightly different concepts, but both are simple. That is why I am doing them in a simple single video. It says, if the resistance of a conductor is 5 ohms at 50 degree and 7 ohms at 100 degree centigrade, then the mean temperature coefficient of the resistance of the material is how much? First of all, what is the temperature coefficient of resistance means? It is known that variation of the resistance with temperature is directly proportional to initial resistance at 0 and also directly proportional to temperature difference between them. So, we can eliminate, so R T minus R 0 is directly proportional to R 0 into T. We can eliminate that proportionality with a constant called temperature coefficient of resistance alpha R 0 into T, where alpha is called temperature coefficient of resistance, which is a measure of how does the resistance varies with respect to temperature. So, if you take this R 0 to that side, R T is R 0 plus alpha R 0 T. So, R 0 of 1 plus alpha T is R T, where initial temperature is 0. But our problem is having both different temperatures at 50 and 100. So, I can write R 1 as R 0 of 1 plus alpha T 1, R 2 as R 0 remains the same, alpha remains same, but temperature is different. You call this as equation number 1 and 2 and you divide 1 by 2. What happens then? R 1 by R 2 equal to this R 0s will cancel, 1 plus alpha T 1 by 1 plus alpha T 2. Now, R 1 is given to you as 5, R 2 is given to you as 7, alpha we need to find out, T 1 is given as 50, T 2 is given as 100. So, we are just ready to apply them in the formula and see what my answer is. Yeah, let us do that as it is given. R 1 is 5, R 2 is 7, 1 plus alpha, T 1 is 50 by 1 plus alpha, T 2 is 100. Let us cross multiply 5 plus 5 into 100 is 500, alpha equal to 7 plus 7 into 50 is 350 alpha. So, 500 alpha minus 350 alpha is 7 minus 5. So, 150 alpha is 2, alpha equal to 2 by 150, that is 1 by 75. So, if you calculate that 1 by 75, you can make it like 100 by 75 and of course, 10 power minus 2. I have just multiplied and divided with 100. 100 by 75 is 25 4s is 100, 25 3s is 75. 4 by 3 into 10 power minus 2, that is 1.33 into 10 power minus 2. To get this 10 power minus 2 this side, I have to write 0.0133 per degree centigrade. So, 0.0133 is best represented with 0.01 itself, because that 33 is ignored in the problem. So, that is the answer, right. So, that is how we solve the problem by using a basic concept, that temperature coefficient of resistance formula, and that is further applied for different temperatures and simplified further. That is how we get the answer. That is the first problem. Let us solve the second problem. This is a much simpler problem. It says, masses of the wires are given in the ratio of 1:3:5. Their lengths are given as 5:3:1. What is the ratio of their electric resistance is? All are made up of same material, copper, that is also important. We know the formula for the resistance R equal to rho L by A. The information about length is given for you, but information about area is not given for you. So, I have to replace the area using a concept density equal to mass by volume. Volume can be written like area and length, area of cross section length. So, in the place of area I can write mass by density into length. I have taken A to this side and density to this side. So, substitute this A in this place, that implies resistance equal to rho L by, in the place of area, mass by density into length. So, when you rearrange the terms, resistance is rho L, denominator of the denominator comes to the numerator dl, where d is density by m. So, resistance R is specific resistance, L and L, L square, density by mass. As the material is same, its specific resistance remains same, its density remains same. So, what we can say further is, we can say resistance is directly proportional to L square by m. So, the ratio of resistance is R1 is to R2 is to R3 is L1 square by M1 is to, because directly proportional to L square and inversely proportional to M, L3 square by M3. Now, let us substitute the data. Their lengths are in the ratio of 5 is to 3 is to 1. So, L1 square means 5 square, 3 square, 1 square. Their masses are in the ratio of 1 is to 3 is to 5, 1, 3, 5. That is what our answer is. So, our answer is 25 by 1, this is 9 by 3, that is 9 by 3, 1 square is 1, 1 by 5. So, if you simplify these numbers further, ratio is 25 is to 9 by 3 is 3 is to 1 by 5. But this kind of answer is not there, right. To get the kind of answer that is there, let us multiply everything with 5. What happens then? 25 into 5 is to 3 into 5 is to 1 by 5 into 5. That does not affect the ratio in any way. So, 25 into 5 is 125, 3 into 5 is 15, 1 by 5 is to 5, both of them will cancel 1. So, the ratio is 125 is to 15 is to 1. This is how we solve this problem, right. These are simple problem, just we need to have basic understanding that resistance in a regular format has to be modified into the terms of mass, because data is given in terms of mass as this formula. Once if you understand that, solving it is quite easy and you can get the answer also easily. That is it. Thank you for watching.